Okay, my people, let's finish up this section and chapter here. I've got about 7 pages left to cover in here. It's really a mishmash of a lot of different little things all combined together. Well, I'm going to combine them together. What is the first of these 7 pages? This one is something that I referred to earlier. We don't want partial credit on our AP exams, so we want to make sure we list the official name of the test, meaning is it the chi-square test for homogeneity or the chi-square test for independence? If you're not quite sure for partial credit, they're asking you, hey, if you're not sure, you're just better off saying chi-square test. So they are implying here that if you get it wrong, you're going to get no credit. So if you're not quite sure, just use the generic chi-square test when you're listing it in the 4-step process. But ultimately, we want you to get better at this. Go to that gaming link we have experimented with in the second semester and practice discovering, is it a chi-square test for homogeneity or independence? Okay, and this is a little review table up top. That's the first thing I wanted to cover. Next one is how we handle variables that are not categorical. So income, for example, is usually a quantitative variable. So how do we kind of make do here in this chapter for goodness of fit and chi-square test for independence and homogeneity if we cannot use a quantitative variable? Well, notice what they've done over here. They have grouped together values in these ranges. And what this does is this forces it now to be a categorical variable. And this is how we get, it's basically a workaround for dealing with quantitative variables. So keep that in mind for FRQ questions dealing with solutions to giving yourself a categorical variable when the given raw data is in a different form, like a quantitative variable. Okay. The next one is what we referred to earlier is when our expected counts are below 5. So you can see some of our expected counts are below 5 in here. All these other ones are good to go. Here's all expected counts. All these are greater than or equal to 5. They're good to go. Remember, these are the observed counts right there. The expected counts are all good except for those 2 in blue. So what we're suggesting here is combining 2 or more different categories. So in this case, what would I do? I would take the next smallest group, which appears to be these values in here, group quarters. And so I would leave that one alone. I would leave this one alone, leave that one alone, and then make this one group quarters and all other responses. So if you do that, then you're going to then you're going to ensure that all of these are um, greater than 5, and you kind of eliminate this other category right there. So that is a workaround for when we do not have our conditions being met for a particular category. Solution, combine it with a different category group. The next one in here. Well, after we do our 4-step process, remember that is an overall test to see if there is any difference or association between 2 or more groups or 2 or more variables and so forth. That's a lot to take in. And especially the categorical variable has a lot of different outcomes in their categorical variables. So the next logical question is to do a detailed follow-up analysis because you're not quite sure of that chi-squared test statistic. Remember, you're getting one for each and every single value within our matrix. And so the combined one we're using to find our p-value, which is fighting against alpha, but usually it is one of these numbers, maybe two, that is causing all the headache of making this much larger. And that's going to give us the detailed follow-up analysis of, okay, of all these different outcomes in here, which one is really making this very large in here, which is driving down P. So let's see that in practice. So here is a situation in an FRQ where they're going to give you information about all 9 outcomes. So what are the 9 outcomes in here? So this is the contextual one with they play different types of music, and then they're trying to see whether or not people order French, Italian, or some other dish based upon the music that's playing in the background. So let's see. In green here, here's all the observed amounts. In blue here, let me clean this up. So in green, here's all the observed amounts. In blue, here's all the expected amounts. And what you're really trying to discover here from our chi-squared statistic of 18, and that's quite large, which one of these 9, or maybe there's more than one, which one is driving this number up? So when I look over here, for example, this is quite small. This one's small. This is having no effect, basically, on chi-squared. The difference between the observed and the expected, you can see, is quite small. So in this one, there are 2 numbers, almost 14 of the 18 values of chi-squared are coming from what? Coming from these 2 little subgroups in here. So in your FAQ question, FRQ question, when they're talking about which observations are driving the chi-squared statistic, these are the 2 that you want to make mention. Okay, let's see another example of that. So, and this one is oh, it's the same exact numbers, just in a different format. I think, yeah, it's the same exact numbers. The next one is different numbers. This is, I forget the context here, with something to do with males and females. I can't tell by this output in here, but you can see this is the observed amounts. This is the expected amounts. And then here are the 4 values that's contributing to the chi-squared test statistic. And by the way, we actually call these chi-squared contributions. So these 4 contributions in here, which one is the largest one? That's what I'm looking for. This one right here. This one is driving up. It's almost half of that value right there. And so in your detailed follow-up analysis, you want to make mention of this particular outcome of that particular subgroup, and that's the one that is driving up chi-squared. What else did I want to make mention in here? I'm going to, in class, we would have gone over, hey, can you guys make an interpretation using the p-value and an alpha level? Oh, excuse me. No, this is an interpretation of the p-value. That's this value right there. That's another cookie cutter example of what the p-value means in context. And this one is the contextual conclusion you can make at the alpha of 0.01. So that was the instructions in here. Interpret the p-value, which we did right here, and then what conclusion can you draw? The conclusion is what we do after the 4-step process. So here's just another example here of a full response, a full credit response for interpreting a p-value, and a full credit response for a conclusion based upon this data in here. Okay, so that about wraps up this chapter. Hopefully you learned something about chi-squared tests, and I'll see you soon.